So, welcome to lecture series on data structures. In today's lecture series, we are going to discuss about tree heredity. Tree is a non-linear data structure. So, initially, when we discussed about the types of data structures, we have discussed two types. One is linear data structure, and the other one is non-linear data structures. So, the types we have seen so far are stack, queue, and linked list. All these three comes under linear data structure, whereas under non-linear data structure, we have trees and graphs. So today let us discuss about the basic terminologies used in tree data structure. So this is a drawing of a tree. So if you draw a tree, what are the parts of the tree that you would observe? So you could see the tree has a root, it has a leaf, it has branches, it has fruits, and it has trunk, right? So now in the previous slide, uh, so from the bottom to top, if you see, initially you will have the root. So from the lowest part to the upper part, if you discuss about the parts of the tree, so the first part would be the root, and the last part would be the leaf, right? So root, then comes the trunk, then comes the branches, and from the branches we will have leaf. So if you consider the parts from top to bottom, which one will come first? Imagine. So let us take this as an assessment. So here, this is one is your tree data structure. Here your root is electronic RUs. In the other figure, your root is A, and the leaf nodes are R&D, Canada, Africa, domestic, Europe, Asia, Australia, TV, CD, and tune. All these things are your leaf node. So what does the leaf node means? That marks the end of that particular branch. So after the leaf, we will not have any other nodes. So this depicts the parent-child relationship in tree data structure. It follows a hierarchical structure. So it is also considered 2D data structure. As I have said before, the first node is your key node or your root node, and the connection between two nodes is called as the edges. So any part of the tree can be considered the subtree, and the last node in the particular branch will be the leaf node. So here are the advantages of using tree data structure. The first advantage is it reflects the data structural connection. And the second one is it supports hierarchical implementation of data. Third one is both searching and insertion operation would be easier in case of tree data structure. So previously we have seen insertion and deletion is easier in linked list, whereas search operation is easier in array. But if you are implementing using tree data structure, all these two operations, both insertion deletion and search will be easier. So here are some of the applications of tree data structure. One is file system. It is also used in the dictionary and in network routing protocols. So here is a small assessment for you. Just go through this assessment. So the question is a tree is given and you need to circle all the leaves. And for the root node, you have to put a square box. And for all the ancestor nodes, all the ancestors of the node 10, you have to draw a star mark around it. So put a big X through the descendant of the node that contains 10. So this is your assessment question. So few answers just by looking at it, you can tell 14 is your root node, 1, 3, 7, and 40 is your child nodes. So keep this assessment for further discussion. So hope you understood what tree data structure is about. So in the next video, we will discuss about the various types of trees, and we will look at each one in detail. So hope you understood this session. Thanks for watching.